just introduce myself and my business partner. I'm Jay Selby. SSEC is our company. And this is Brandon Coppage. He's my partner in the business. Been around for 50 years. My dad started this company in '68. So he was a little ahead of the curve even before the EPA and other things. So, and we've done a lot of projects, a lot of your guys' work over the years. So, including Oroville Dam and some other big ones. So I kind of try to put in, sorry, I'm not a public speaker and my allergies are kind of getting me. So my voice sounds like it's shaking a little bit. It's definitely because it is. So I try to put this together for you guys, looking at it from your guys' angle back on like how to set up a job from the start and then on all the way through inspections and maintenance. So that's kind of how we kind of try to outline this this presentation for you. So first off, we're going to be talking about the difference in the different hydraulic methods, the different applications, and then where those are effective, where they're not effective, and then also where different BMPs might be mixed in the middle of that as well. So, so the keys to a successful erosion control project are going to be to conduct a soil test. Now, this is something that we've been working with Caltrans a lot on the last 3 years, really, is really getting in there up front and getting a soil test done so we know what we're working with. Now that can be very difficult because a lot of times the dirt hasn't been moved yet. And a lot of times excavators will go down 20, 30 feet, so you don't really know the soil conditions of what you're dealing with until the grading is done, right? But it is very key in having a successful project. We'll go deeper into that later. Start at the top of the hill. Erosion always starts at the top and works its way down. So if you have a small problem at the top, it's going to translate to a huge problem at the bottom of the hill. Use an effective combination of practices, which are BMPs. Site preparation, which we'll go into more of that, but certain things with disking and track walking and things like that really prep the soil well for the seed bed. Planting appropriate vegetation, so that's your selection, your seed selection. You know, are we going to go native? Or are we going to try to stick with what's indigenous to the area? Temporary mulching, and then follow-up inspections. So, you know, there are there's many methodologies for temporary, but a hydraulic application of hydromulch is definitely one of the most cost-effective ones in regards to, you know, stockpile maintenance or things like that. You know, there's temp cover with plastic, and that can be kind of a bear to manage throughout the winter. So hydraulic methods definitely are the best cost-effective ways. To understand the soil is really what we're trying to do. And if you look at the different layers of humus down to bedrock on this screen, as excavation of projects happen and an excavator takes more and more dirt off the top, we're left with this weathered rock fragments, and now we're trying to, you know, sustain plant life. We're trying to establish natives when we're down to that layer. So that's why the soil test is really so important, because we need to know what we need to do to help that soil start creating a good seed bed. So Soils 101 is if you take care of your soils, then your soil will take care of you. So again, this is the soil test. I meant to bring a couple of little kits, but you know, I don't know if you guys are all familiar with soil tests or not, but you know, you go around your project, you pick a few spots to dig up, you know, a shovel full, maybe put it in a 5-gallon bucket, mix that soil up so it's kind of showing representations of all over your project, what it's seeing. And then you can real easily throw it in a bag to send it to a lab. It's a less than $100 test, and now you have something to go off of. So again, this is, like I said, this is something that I think Caltrans is right there. They're just about to pull the trigger on their new spec writing and make this part of every project moving forward. They're just trying to figure out where to plug it in, you know, because from a contractor's side, we've already bid the job before the excavations happen, and then how do you manage that?
Can you do it? Yeah, a lot of our work we do foundation course, and maybe we could test at the level of excavation. So we'd have to work with geology.
Exactly, but it'd be great to do up front, because then you can know your right fertilizers, your right amendments, and we'll go a little bit deeper into that too. But yeah, that's a great point. They don't usually do that on like Caltrans style work, but your guys' work, yeah, with the core samples, yeah. So soil texture, erodibility. So describes the three sizes of soil particles, which is the three major ones are sand, silt, and clay. And I'm just going to roll right onto the next slide. This is a great tool to kind of figure out what kind of soil we're dealing with. And if we know the erodibility of the soil, we know its characteristics, it's going to be easier to design, implement a good, either hydraulic or BMP solution to make sure we don't have erosion. So you can kind of just see there, on the scale of where they are, and then you kind of have to, after your soils report back, you kind of look at where you're at on this triangle, and then say, okay, some of these hydraulic methods might not actually hold up. We might have to go to a rolled erosion control netting or something. Okay, so importance of soil texture. So drainage, the water holding capacity, the aeration, the susceptibility to erosion, the organic matter, the capacity, and the pH capacity and buffering. So those are the main things that we're looking for when we're looking at the soil texture. Soil fertility is the ability level of soil to grow and support plant life. Fertile soil contains the sufficient minerals and nutrients needed for plant growth. So 16 of the 90 chemical elements on the Earth's crust are essential for plant growth. So 16 out of the 90 are essential for plant growth. 7 of those 16 are necessary that are called macronutrients, which are there in the middle, and then the micronutrients on the right are the other elements. So here's our macros. We have hydrogen, oxygen, nitrogen, carbon, phosphorus, potassium, and calcium. So that's what we need to get growth. So again, the soil test tells us a lot. So now we can run a soil test and we can look at our soil pH and find out what's going on there. And there's a lot of amendments that we can utilize to balance the soil. But the problem that we see a lot is we do a lot of projects where it takes 6 months, 9 months to realize there's an issue. Like, this didn't grow right. Like, what's going on here? So now you've kind of lost a whole season, really. So if again, I'm just the importance of trying to get this stuff done up front. It kind of gives you a better and easier to look at screen here. So kind of gives us our tables and what we're looking for, those macronutrients, like I said, and seeing where we're at. If we're way too acidy, if our alkaline's way too high. And again, this is just all tools we can use to design better fertilizers and amendments to go along with it. So any questions so far on soil testing or pH levels, anything like that you guys can think of?
I have a quick erodibility question.
Sure.
You were talking about how soil texture impacts erodibility. Is there like a rule of thumb on what proportions make something more prone to erosion? Or?
So yeah, clays are generally a lot less susceptible to erosion as a sandy or silty soil, but you really want a mixture of. You need all those elements in any kind of soil, but you want a mixture of more of a balance, I should say. If you're dealing in sand and silty, where it's 70-85% sand and silty, it's definitely going to have a lot more erodibility. So, does that make sense?
Yeah. Does what you were talking about how sometimes you have plants and weathered rock fragments are the gravel size component that also contributes to erodibility?
Yeah. The deeper they dig, the deeper an excavation project goes. I mean, obviously, the more rocks and everything that come into it, but which doesn't have as hard of an erosion standpoint, but you've lost all your nutrients on top of it. So it's kind of like right. One or the other. So in that case, if we can. I mean, I love projects. Our best projects are projects where people strip the topsoil and set it off the side and then do the grading project and put the topsoil back. Get us some humus, get us some decent, that first 6-inch layer, those projects grow great. So that would be my suggestion there. So this slide just really shows you, and I talked about it earlier, that, erosion starts on the top of the hill. And so if you don't spend the money on the top, by the time you get down to the bottom, you've really cost the project a lot of money. If you have to go back and repair these slopes and rebuild them and then revegetate again, just by not, ignoring a problem of the erosion on the top of the hill, it's just not smart, So preparation. Slide showing track walking now, especially with you guys. You guys are dealing with levees and all kinds of different projects. Well, when they build slopes, they always build them sideways. That's how the way the dozers work. And a lot of times, especially we see this more on I'd say private projects, not on government projects. But the grading contractor wants to walk away from it at that point, where the vertical track walking is huge because it does several things. For one, horizontal track walking already creates a rivulet in the ground where possible erosion could happen. Plus, the water speed as it runs down that slope is going to be increased. On vertical track walking, we've done a few things here. We've created a seed bed for a little area, a little catch basin to hold moisture and the seeds. So whereas horizontal track walking, the seeds could end up at the bottom of the slope. Vertical, we've got a nice little seed bed prepared for it, and again, less susceptible to erosion. So I'm a big proponent of that. There are other types of preparation that you can do, whether it be, there's lots of farming things out there, ring rollers and everything else that prep the ground. But honestly, for what we do, I feel track walking is the best.
Oh, in the levees, it's the most common because the civil contractor hates to do this method because the levees aren't tall enough for them to really go back and forth. So it takes a lot longer for them to do it. It's costly. So you see they'll run the tractor sideways along it the whole time and call it done. And it's probably the hardest to recover from.
Yep, agreed. Okay, so we'll talk about some of the seeding now. So, again, there's various methods, tractors, hydro seeding. I wanted to kind of go into actual seed because I think, looking at this more from an inspection standpoint from you guys, this is your variable, okay? There's kind of standardized pricings across the board on a lot of products that are used in industry, for our industry. But the seed is the variable because we're always trying to get that native mixture. And I think from an inspection standpoint, I think this could be a helpful tool for you guys in the field, knowing how to read seed text. This is a lot of our job is doing this. Is helping agencies and stuff we work for understand what we're doing and helping them inspect us better, right? So this shows you when seed comes in, they assign it a lot number. It might be 2,000 pounds of, California poppy, whatever it is. And it's assigned a lot number and it goes out to laboratories for testing. And this is the start of it. So I'm kind of just highlighting here, this Bromus carinatus, which is a native brome. And the germination is 93% on this. So this is the start of it. It rolls in from there to a seed tag, which is how we purchase the seed now. It's sealed in a bag. It's got a tag on it. It's telling it, what the seed is, what the job is, what the lot is. If you can see the lot number there. So anything that was tested in that has to be in that lot number. And then again, it's still consistent with the germination of 93%. And then kind of important too here on the bottom is the test date and the sell by date, because seed is a living thing and it goes bad. So you guys need to make sure that whoever's doing this on your project is staying current on all this stuff. This becomes, from a seed company standpoint, this becomes what they call the mix card, because most of the seeds that you guys purchase or put in your specs, it's a blend. And so it's all blended in a 50-pound bag, and it comes with a tag that I'll show you next. But this again just shows you what they come up with to do their math to make sure they're hitting the right percentages of every seed. And then this is actually what you guys would see on your job site.
How does that work if you've got different lots of seed based on their speciation?
Yeah, that's why we don't order seed until it's ready to be placed, because once you blend it in the bag, you're done.
Does it go to the lowest sell-by date?
In that case, yeah, it would. Yeah. So we generally don't order it until we're ready to use it. So, but we're making sure that the lot numbers are, the seed companies we're buying from are testing and staying up.
Yeah, but you're not the one mixing it; it's the seed company.
Correct. Yeah. Exactly.
So some agencies, SFPUC is probably the most famous for being a very stickler on their seed. So a lot of times we actually order it at the beginning of the project, and then they set a time mark where they gotta have the seed in, but sometimes the civil contractor won't get it done in time, we'll have to reset, but they'll require retesting, recertification on everything through.
Yep. But yeah, so again here, it's showing your purity, showing your germination, but it's not really showing your pure live seed. It's a 50-pound bag. These are just all things during the inspection process they need to make sure that, that they're looking for. Bulk seed is what it is. So if you buy 50 pounds of bulk seed, it's exactly 50 pounds. But if your germination is only 93%, and then, actually, let me go back. Let me go back a couple slides. This will make more sense. So, okay, so see down here, so we have a germination of 93%, and then we have inert matter of 0.78%, and then weed of 0.55. So that's how they figure out that germination right there, okay? So if you ask for 50 pounds of pure live seed, in this scenario, you'd probably end up with 60 pounds of bulk seed. Does that make sense? So you're really getting what you're paying for. If you've got a seed with a terrible germination, like say it's 40% germination, and you're buying 5 pounds, you would need like 20 pounds of pure live seed to make up the difference. You know what I'm saying? So you're actually getting what you're paying for, which is the correct way to do it. But really, only state agencies and government agencies run off pure live seed.
Is there a recommendation for some other measure other than pure live seed? If the government agencies are the only ones using it, is there a reason?
I mean, it's the correct way to do it, the pure live seed, because as a landscape architect or a botanist, you're trying to achieve a certain goal. You have a goal in mind. We want to revegetate this site. We want to get the right amounts of seed per acre or per square foot. We know we can sustain 8 varieties of seed. And so when they're doing their designs, they're not just guessing. Because I actually almost brought this as an example, but you take a pound of, say, barley, and you take a pound of, say, California poppy. There's 1 million seeds in the California poppy pound, whereas in the barley, there might be like 100, you know? Or that's probably too low, but it would be not a lot, a lot less. So when they're doing their selections as the botanist or the landscape architect for the project, they're trying to nail it in on what that square foot of land or what that acre can sustain in plant life wise. So if you had a really, really poor germination on one of those seeds and you didn't use the pure live seed method, then you wouldn't get to your end result. But it does. The price goes up quite a bit on our end from purchasing it when you pull in the pure live seed factor, because the seed has to come up so much. So this just kind of gives you an example of seed tags. I've seen out-of-state seed vendors try to, work into California, and they're not following the same guidelines as the better California seed companies we have, like Hedgerow and like Pacific Coast Seed. They're both great companies to work for. But I just wanted to throw this slide in there so you knew what you should be seeing on every seed tag. So it kind of gives you, just a quick, and then that's where you see that hard seed and germination, and you're going to see the hard seed in the pure live seed tags, because now you're really measuring hard seed versus soft seed, which soft seed is your fast germinator, your fast popper, and your hard seeds usually wait 2 or 3 weeks later to germinate, and that's just Mother Nature's way of protecting itself. So again, all factors on the pure live seed. So again, when I was putting this together, I was thinking about your guys in the field and, where could this be useful? So I threw some slides in there. I thought, this would be something an inspector in the field could just plug in his laptop and go, oh, okay, let me double check this. Oh.
Question, does the same species of seed have a hard and a soft, or is that different species?
Every species has a hard and a soft. Yeah, so they'll just, that tag will normally say the percentage, but yeah, they'll have, exactly, every species has hard and soft seed in it. So we're trying to identify why that matters to us is if the percentage of, for a landscape architect or a botanist, if the soft seeds say was only 10% of the mix and the hard seeds were 90% of the mix, this project's going to take a little while longer to establish because those hard seeds are going to be behind it. And as winter's approaching, we get some natural rains, we start getting the dew, we start getting the cool down, and that's when the seeds start germinating and growing. Now, if there's a really fast cold snap, everything stops. So from the way I look at it, from my perspective, is I'd like to have a good blend of soft and hard seeds in the species to ensure that that's going to take off and it's going to grow. So one of the things that I kind of threw this in there for you, one of the things you mentioned on your email was equipment wash certifications. This is something we're seeing more and more of now, and this was one I took from a wind farm project we did in Livermore. So anytime any new equipment came on the job site, and this isn't specific just for hydroseeders, but it kind of is in a way, because any invasive weeds can be transported by any vehicle. But now with a hydroseeder, you've got a tank, and that truck was on a different job the day before. Let's just be honest. He was out shooting some subdivision in Elk Grove, and now he's showing up on your levee the next day. And how do you know what you're really getting on your levee? So I think it's important, we're trying to push this too, moving forward, that you get wash certificates from your contractors, and that it's verified. I mean, you really don't want to, like I said, they could be planting something totally different. They might be doing an athletic field, right, with that same hydroseed equipment, and now you just put a sports blend on your levee. So kind of hard to see in the room right now, but I want to talk a minute about compost versus biotic soil medias. So biotic soil medias is something that's relatively new to our industry, and it's kind of a compost replacement is what it is. The slide on the left is Southport Levee. I don't know if you guys are familiar with that. So 5.5 mile new levee project. In the basin of the floor down here, we were grain drilling, spreading compost, adding amendments, native straw, and then we were rolling a netting over top of it. But can you see from this tractor and this compost spreader, can you see that dust cloud all the way to the water? We're having more and more problems with the Air Resource Board and the Clean Air Act on some of the products that we've generally been using for ever in erosion control, which blown straw is one of those as well. We're getting a lot of dust coming off the straw. So now you have the water board and then the air board kind of fighting a little bit each other, because the water board's telling us, oh, but we want straw on this project, and then the air boards go, well, we don't want all the dust it's creating. So something we've been utilizing a lot on, and this other slide to the right is showing a hydroseeder put on this Proganics material, which I don't know, Brandon, you want to maybe grab that and pass that around the room? So what we're trying to find the right recipes to put amendments and get stabilization and get growth. And so we've found that in some cases these new soil medias, like this one, it's called Proganics. It does a great job because we can hydraulically apply it. We're still getting a ton of nutrients there for the plant life. So just something to think about, and it just depends where the project's at, really. If dust is a major issue or not. He's going to pass that around, but it actually has. I was actually surprised. This is the slide on the right is the Highway 65 bypass widening job. I don't know if anybody lives in Roseville or drives that at all, but that whole area has been really congested for a while. Again, we had commercial buildings, we have the mall, we have everything right around there, plus live traffic, and so Caltrans agreed with us on this one. Like, yeah, we don't really want that dust flying everywhere around here. So that's the project we used this one on. So types of surface mulches. So in fact, this is where we'll just start passing these things around. So we go through all the different mulches that we might be used, and we didn't bring a bale of straw in here for you. So, but there's wheat or rice straw is a typical mulch that's used for erosion control. We generally like to use rice more than wheat, unless you're wanting to plant wheat on your job, because that's what you're doing when you're using wheat straw. So rice only grows when it's submerged in water. You've seen rice fields before. It has to be completely submerged in water to grow. That's why we love it with native seed mixes, because it doesn't grow. So it lets all the natives establish. Okay, so then we have a couple of the other different fibers, which is wood fiber or recycled paper fiber, whose Brandon will start handing those down. Again, these are all, I just kind of given the broad scope. They all work, relatively the same on the fibers. Compost can also be a surface mulch. Its erosion control value maybe not as good But we've been playing with compost berms and things like that that actually have been holding up. It's kind of, I think the jury's still out on them right now. Is kind of how I feel about it. And then of course we have erosion control blankets. So this was a Caltrans study that they shared with me. That I mean, it's pretty basic. I mean, 0% coverage, 100% erosion control. 100% coverage, 100% erosion control. So, you know, it's just you need to cover the ground completely with something, because if you leave 10% of the ground opened up, you're going to have erosion. Let's talk about how long some of these measures will last. So by themselves, straw mulch, either crimped or tackified by a hydroseeder, is a one season application. Most hydraulic mulches with AcaFire 1 season, unless you've added seed to the mix. The bonded fiber matrix and the erosion control blankets can last longer than a season, but again, until you put the seed component in there and really establish growth, you don't have permanent erosion control. So we apply straw. We generally do that at 2 tons an acre, which is about 50 to 70 bales per acre, and it can either be done by hand or it can be done with equipment. But again, let's see the dust coming off this machine. Okay, so if you're putting straw down, it needs to be anchored in some fashion, which that's either, like I said, crimping or using a hydroseeder and a hydromulching over the top of it, which that is, you know, mulch and glue, or rolled netting across the top of it there. So that's Highway 65 on the bottom there, some of the approach slopes. We're going to a lot of no net blankets. Honestly, there's a lot of Curlex and other style blankets that are locking themselves together without nettings.
All the blankets now are all natural, so they use a hemp weave in lieu of the photo net now. So you can actually get coir straw coir mixes, all with a all natural blanket, or all natural netting on both sides. But we're seeing a lot of TRM's been a plastic use blanket that's been used in waterways a lot, and Coir's finally came up with 980 and some higher flow rateable netting that will actually hold back or meet the water regulations, but not capture any of the wildlife issues. So we see the, I can't think of the animal, Fish and Wildlife. They've actually started pushing more towards the coir and away from the TRM, which is that turf reinforced matting that we used to put in streams 5-6 years ago, and they faded away from that a lot.
Yep, exactly. Okay. I was going to go through some of the different AcaFire types. So we have our three major plant-based AcaFires. So this is a glue that's derivative from plants. So we're staying green. We're using Mother Nature to help us out in erosion control. These are typically the main three that we use. Psyllium not so much anymore. Guar and Plantago the main two. And then these are non-plant-based AcaFires, which I feel like had a lot more impact in our erosion control world maybe 15 years ago, and it's kind of been fading off ever since. There are some questions on, if copolymers and polyacrylamides should be introduced with some of our aquatic friends. So we generally like to just stick with the plant-based ones if we can. But there are places that polymers can be effective and can help, but it's more on the dust control side.
Right, we've used them in Southern California when we had seriously steep piles and dust and high winds, and we needed to glue it together. We use things like rhino snot.
Exactly. Yep. Same thing I was thinking of. So okay. So keys to successful installation on erosion control products. So our site preparation needs to be good, especially when you're dealing with rolled erosion control, any erosion control blankets. If you don't have soil contact, it's pointless. So having somewhat of a workable surface is great. Seeding, stapling to the soil surface, or overlap, and is it trenched? and then follow-up inspections. So I'm going to go through this kind of quick because this is going to kind of show us an idea. So this is a proper installation. I've got another slide I want to show you too. This is typically what we see with, we call it kind of the burrito wrap, where the key trench is cut, the blanket's laid through there, it's backfilled with soil, and then it's flipped back over itself. You'll notice that the direction of the flow of water is heading this way. So your overlap is working with your direction of flow. See that? We're breaking up the water that's running down on the original blanket. This one is bundles of light branches, but that could be fiber rolls, that could be anything that's breaking up that sheet flow. And what we're trying to do there is just really try to slow the water down. So then they got the proper pinning installations here, and it's just a good little diagram to show you how to do it. This is, again, that same project I was talking about, Southport Levee, that we just finished up for the Corps of Engineers not too long ago. There's a few things going on here, so I'll kind of talk through them. So what we did up here is this contract breached the levee and created a low flow channel that works its way back up the project. You can see it already started growing on us while we're still working there. We didn't know we were going to encounter, but we did over here, an Indian burial ground. So the way that we were going to install this blanket had to change quite a bit. So first off, our overlap on the low flow had to work with the directions there. We have a slope working down this way, a slope working down this way. So our overlap and our trenching patterns had to match. You can see on the low flow channel, we had to trench both here and over here in. And then as we're working off this Indian burial ground, we have to keep the blankets going the right direction for slope and flow. So this kind of, I just came across this photo, I thought that's a pretty good one. Because then we had to do another key trench here to protect that frontage of the water, and then run the overlap a little bit differently over there. So I just thought it was a good slide, kind of showing you like proper installation. Okay, now we'll talk about hydraulic mulches and where they generally work well. And this, I put this slide here just to kind of show you the steepness of that hillside and for access, because obviously blanket would be outrageous and you're not going to blow straw up there. So threw this in here just because, especially for your inspecting side, you're going to have all these contractors come out with different size equipment, and you're kind of working everything off the square foot or the acre, and you got to be able to do the math, make sure that whatever equipment they have, that they're actually doing what they're supposed to be doing. So, obviously this is like a 4,000 gallon hydro seeder, where this is a 1,200 gallon. So depending on your size, you need to be able to pivot and make sure that your contractor is giving you what they should be giving you. So, that's a discussion you have with them up front. It's like, okay, what's your capacity? What's your size? What's your plan of attack? How do you achieve this pounds per acre? How do you know that you're getting the right amount of seed down per acre? So again, this is just conversations that should be taking place before anybody starts work on one of your projects. So the common aspects of the hydro seeders is a tank for holding and mixing water and seed, soil amendments, and mulch. So then it also has a mechanical agitation system. So the material's being mixed and keeping everything consistent. So why that's important is if it wasn't continually being agitated, or if you didn't have enough mulch, or a lot of times the seed will float to the top. Now all of a sudden you're spraying out the whole tank, and all your seeds on the last, it's a little stretch. So to have an agitation system is very important for that. They'll have pumps to spray the mixtures, and the applications either by the tower, which is on top, or by hose and a hose reel. So when to use hydraulic mulch? So like a lot of farming methods work, and we've used farming methods on DWR projects in the past where we've broadcast seeded, grain drilled, done something like that. But when you start getting slopes greater than 3-to-1, things like that, you really need something else. You need something else to hold it. So in that scenario, especially with a tall slope, we recommend hydraulic mulch. Straw can't be anchored there. On site where soil preparation is not feasible, or where other soil stabilization methods result in unacceptable levels of ground disturbance, and where it would be difficult or impractical to install erosion control blankets. So we run into that quite a bit too. And again, when you start getting the erosion control blankets, the price of the project's going up. When to avoid hydraulic mulch applications. So this is kind of what somebody mentioned here earlier. In areas of concentrated water flow, such as ditches or swells, we see this quite a bit, especially with straw mulch. If there is any kind of concentrated flow, I mean, the straw mulch just picks up, travels down with it, makes a big berm somewhere, and then you have another blowout so downstream somewhere. So do not use hydraulic mulch without including a tackifying agent, such as Aguar or Plantago. Hydraulic mulch on its own without the glues, it's just going to wash away the first rain. There is a curing process for all these glues, and not depending if it's BFM or Aguar or Plantago. Generally 24 to 48 hours. So you'll see in a lot of Caltrans specs that no hydroseeding or no hydraulic applications will be done within 48 hours of a rain event. So they want you to have it done, and so that these glues can actually set up and do their work. Once they're dried, once they're fully cured, they don't re-emulsify. So now you've got this solid crust. Okay? Do not use where equipment access is an issue. So again, it's not meant to hold up to traffic. And do not use seed in environmental sensitive areas without prior approval. So, which you guys always do. Hydromulching versus hydroseeding. So in hydroseeding, seed soil amendments mixed up, applied hydraulically, and usually that is followed by a second step. That's usually not enough. So the second step could be another application of hydromulch, which I didn't say it, which the difference between hydromulching and hydroseeding is that of seed. So if we're talking hydromulching, it's like it says there on the slide, involves mixing of mulch and tackifiers applied as a one step. Now in hydroseeding, after the first step goes down, after the seed is as close to the soil as possible, you want your seeds down as close as possible. You don't want to develop air roots or anything like that, which can happen. Like if you did a straw mulch and then try to hydroseed over the top of it, that little gap right there could develop the seedlings air roots. Yes. Okay. So a second step is generally going to take place, whether that be another layer of hydromulch or an erosion control blanket, but it needs something to have that protection layer. Just kind of went down. Again, I was trying to think about your guys in the field, so I just went down. Types of mulches, what they would normally see, the properties of them. They're generally in 50-pound bags. There's a lot of different types of fibers out there in the market, but these are kind of the more commonly used ones. Almost all of them have a green dye, but not all of them. I've actually used some mulches in the past that didn't, and it's kind of a head trip because you're just so used to seeing green. But and then all mulches will do better with a tackifying agent of 10% of the weight. So you got a 50-pound bale, 5 pounds of tackifier. That's kind of the general rule of thumb. So commercial product categories, things you should know. There are many commercial product categories for hydraulic mulches, and most have been defined by manufacturers, not end users, which can be actually a problem sometimes. All hydraulic mulches work about the same and perform much better if they include a tackifying agent. Better erosion control on steeper slopes is achieving by a hydraulic matrix. So that's, again, BFM, bonded fiber matrix. In the bonded fiber matrix, the factory that's making the mulch is mechanically securing these fibers together through a heat process and then adding the tackifiers directly in the bale. We can't recreate this in the field like they can do in the factories. So that's where these BFMs really come key, but they're also a lot more expensive as well. And then to keep costs down, most of these products are made in Oregon, Washington, Idaho. We generally don't use the same mulches that the East Coast uses, just for trucking reasons and things like that. I want to go through application rates because this is a problem I see on a lot of your guys' projects. Is you're not getting what you're paying for, So it's really hard to track on the inspection side, companies like us, of how much are they really getting out there, unless you're bale counting, pallet counting, pre-measuring everything. So I just did a few slides here to show you, a 2,000 pounds per acre of any hydraulic mulch you shouldn't see the dirt. You shouldn't see any dirt unless it's a severely track walked or uneven surface. 2,000 pounds now has to spread out over more angles. But if it's flat, generally you're not going to see any dirt. 500 pounds, you're going to see a lot of dirt showing through. But with a BFM of 3 to 4,500 pounds per acre, I mean, it should be a coat. It should be a real layer on there, and it's an easy thing for people to cheat on. So now we're going to talk about those same application rates. How does it work with actual slopes? So we like to spray from multiple directions if we can. We're trying to get that, three-dimensional coat to a project to where anywhere you look at it, there's going to be no shadowing. And this will kind of show you an idea. So that's a track. It's hard to tell, but that's a track walk slope. So it was vertically track walk from here to the top, and they sprayed it from one angle, and so the mulch grabbed every other track. See how they sprayed it from one angle, it didn't hit the other angles. It's gonna fail. It's not gonna hold up. So 3-dimensional spraying. All right, this is an old picture, and it's kind of interesting to me because this is the 1981 Oakland Fire. And my dad was pretty heavily involved in this project, and I was pretty young, so I don't remember too much of it. But they were really concerned about landslides. I mean, it's the worst thing about a fire. We do a lot of firework. After you have a fire, you're susceptible to a mudslide, and now you have more loss of life, or property damage or loss of life possibly. So in the Oakland Fire, these poor guys are on this hillside trying to get these erosion control blankets in place. Obviously, the soil's not prepped; it's a fire, so everything's going to be uneven. You're going to have sticks. You're going to have just things. Just a really not the best scenario to be rolling out blankets. Plus, look how unsafe that looks. Just from a safety standpoint, they look like they're about ready to fall off. So the California fires led to the development of the BFMs. So this is a picture of us working in Santa Rosa a couple years ago, and very, very steep hillside. There's no way to get blankets in there. There's no way to hardly even walk through there, especially after a fire. You've got trees and everything else. So that's where these BFMs were developed. So design is highly effective spray-on blanket. Oh, where'd I go? There we go. Where applied where site preparations are impractical. Apply where slopes were steep and accessible. Health and safety issues with workers on slopes, and cost-effective alternative to previous methodologies. So I didn't know that was the history of BFM until I looked that up. So that was kind of cool. Learn something new about your own industry, right? So it's just an example of proper applications. So, you see here, a very uniform. I actually took this picture myself. It's drying out in the center a little bit because of the coats of application, but it's very even coverage. Same here, down here. This is actually in Santa Rosa, on the Santa Rosa Fire Studio. Very even coverage. And here's some bad examples. So poor coverage, your dirt's wide open. I mean, it's almost pointless you even did anything. Handbrake has some seed and hope for the best in that case. And then also to here, waterways. So, this is an area underneath the bridge with raising and lowering waters, receiving waters. And so hydroseeding, not effective, obviously, And then the ugly, which is no matter what you do, sometimes you're still going to have a slip out just because of, improper compaction or oncoming waters, things like that. So then it's all about, after you've done a successful project, it's all about the maintenance. So good applications of hydraulic measures generally result in the uniform development of stabilized cover. And that's the end of the day. That's our goal right there. We want a green carpet. We want very little soil exposure to cut down on the chance of any kind of erosion. Inspect regularly during the winter and after significant storms. I don't know if you guys can see here, but the silt fence is knocked over. Obviously these rocks have been tumbling down, so keeping up with the maintenance. If hydraulic mulch is lost, we might need to reapply throughout the winter to guarantee that we can get it stabilized. And again, here's a couple of slides here. You can really, there's a lot of reeling going on here. And so this is a reapplication. So if reels and gullies have formed, we rework the slope if you can before reapplying a hydraulic mulch. If the vegetation has not become established during a normal time, reapply as well. So I think that is it. So any questions?
Do you have a preference for organic tackifiers over non-organic tackifiers? And organic here, like you talked about acrylic tackifiers?
Yeah. You know, the organic ones, like I said, are mainly Plantago, guar, which guar is the best tackifier out of all of them. When you start dealing with copolymers, there can be some issues, like talking about earlier about they're really good for dust control, but necessarily not erosion control or plant establishment. Sometimes they can actually create too good of a crust. So a lot of the copolymers are kind of related to the paint industry. A lot of it can be paint byproducts. And so again, not the healthiest thing. Works great for like a temporary helicopter pad in the Middle East. That's one of their biggest sellers. That's where most of those products are sold. But yeah, so I would, if you can, guar is the best organic one that you can spec.
You mentioned typically it comes in green color, but you haven't seen it in others. Do you then spec that out? And
yeah, it's really a tool for us, but it's become an industry standard. It's kind of funny. So I can tell you a quick story about the background of that. So my dad, like I said, was involved in this from 1968 on, so he helped develop a lot of the materials used today. So the first fibers ever was a fiber by Weyerhaeuser, and it was used to screen peach juice. And so it had a slight tint of peach dye in it, so that all the peach juice looked the same. And when we went up to Oregon to talk to him about making fibers for us, he said, well, can you change that color? And they go, yeah, what color do you want? Make it green. So that's how that started. That's like back in the late 60s. And a couple of fiber manufacturers have tried to pull the dye out of it, and the customers and us as contractors and the customers, nobody liked it. We've all gotten used to it.
Good presentation. Thank
you. Yeah. Perfect. All right. Thanks. Well, thank you, everybody. Appreciate it.
Appreciate you taking the time and effort. It's very appreciated.
Yeah. No, definitely. Yeah. Thanks.